in the previous lectures, and we have done what is the definition of a Fourier series and how to find out the Fourier series with the help of Euler constants. Euler constants was A0, A, and Dn. And we have talked about the Fourier series with the range 0 to 2 pi with a period 2 pi. And in the previous lecture on yesterday, we have discussed the Fourier series in the range 0 to 2L or minus L to L, and with the period 2L. And this was called change of interval. And we have also discussed the Fourier series for a discontinuous function, and also discussed about Dirichlet conditions. Now, in today's class, we shall discuss the Fourier series with a half range. Earlier, we have discussed the Fourier series with the full range. Now, we shall discuss question in today's class with the period 0 to pi or 0 to limits with 0 to pi, and the period become pi. And also we can find out the Fourier series of a function with the range 0 to L with the period L. Now, if you compare these periods with earlier there was a 2 pi and 2L. Now, if we observe, in place of 2 pi we have pi, in place of 2L we have L. What we can say, this was your full range, now this will be your half range. So full range and half range, it means we shall discuss the Fourier series with the half range in today's class. Now they can ask questions about how to find out the Fourier series with the half of the range of a function. Suppose we have a function f of x with the interval 0 to L. Then it is clear this is a question of a half range because the period becomes L in place of 2L. It means they can say either to find out a half range cosine series or half range sine series. We can say that find the cosine series or find the sine series. Half range, always keep this thing in mind. Then the half range cosine series will be fx is a naught by 2 summation a n cos of n pi x over L, and n will be 1 to infinity. This will be your half range cosine series, and the half range sine series will be fx is the summation bn sine of n pi x over L with the limits n is varying from 1 to infinity. Now here we need to find out these Euler constants a0 and an. How to find out a0? That will be 2 over L, and the range is clear, that is 0 to L, and we need to find out f of x dx. And similarly we can find out the second Euler constant an, that will be 2 upon L 0 to L f of x into cos of n pi x over L dx. This will be the method to find out the Euler constants a0 and an. Similarly, we can find out bn also, that will be 2 over L 0 to L sine of n pi x over L dx with f of x. So these are the formulas to find out the half range sine series and half range cosine series. The question comes, if in place of period L we are with the period or we are in the interval 0 to pi. So if the function is f of x in the interval 0 to pi, clearly the period is pi. Question is of a half range. Then what will be the value of this series? The series will become, you just see, series will be fx is equal to a naught by 2 plus summation m is 1 to infinity. Just see, in place of L we have pi. The period is pi now. What will be the formula? It means in place of L we need to substitute pi here. So that pi will be cancelled with this pi. We will get a cos of nx. And the formulas for a0 and an can also be written. That is 2 over pi 0 to pi f of x dx, and that is 2 over pi 0 to pi f of x into cos of mx dx. These will be the new formulas for the period, and the formula or the series half range sine series will be summation m is 1 to infinity bn sine of mx, and the Euler constant bn will be 2 over pi 0 to pi f of x into sine of mx dx. So this will be the Euler constant in case of uh, Fourier series with the interval 0 to pi. So there are small changes for the different intervals. Now let us start with an example. Find out the half range sine series for the function f of x is equal to 100 in the interval 0 to L. You need to find out the half range sine series. Clearly, the interval is 0 to L with the period L. So the formula for the half range sine series will be Bn sine of n pi x over n. This will be the formula for sine series, and the constant Bn will be 2 upon L 0 to L f of x into sine of n by x over L dx. You just need to integrate this 2 over L. Clearly, f of x is 100. It is given to us. Now, the integration of a sine will be minus cos n pi x over L n pi over L with the limits 0 to L. You can substitute the limits. It is 200 over L, and what it will be, that will be L over n pi. Reciprocal, and this negative sign can be taken here. L can be cancelled, or you can substitute the limit L. When you substitute L, L will be cancelled with this L. Ultimately, you will get cos n pi. And we have already discussed the value of cos n pi in the previous class, minus 1 raised to power n. And for lower limit 0, cos of 0 is 1. So this will be your value minus 200 over n pi into minus 1 power n minus 1. You can also discuss the even odd case, and clearly this value will be 0 if n is even, because if n will be even, minus 1 raised to power even will be 0. And when n is odd, the value will become negative 1, negative 1, negative 2. And you will get that negative 400 over n pi. So this will be your value in case of n pi. So now you can put the values in this series, and what it will be, that is n1 to n20. Sorry, the value is for odd natural numbers. So we will not write n is 1 to infinity. N are odd. Odd numbers are, you can write odd, and the value is 400 over n pi into sine of n pi x over L. Now you can expand the series by using the values of n, that is 400 over pi, can be taken out when n is the first odd number, that is 1. This will give you sine pi x over L and over 1, n for 1. And for n is equal to 3, you will get sine 3 pi x upon L over 3 plus so on. So this is your required Fourier series of the given function. So as a particular case, we can also discuss when the question come for, suppose as a particular case, they give you the question for 0 to 2. It means the interval is 0 to 2 with the period 2. And then clearly, and they have said that find the half range sine series. So ultimately, you will complete the question with L. And then what is the value of L given to us? That is 2. Now you can substitute the value of L in this series. 400 upon pi, and you will get that is a cos, sorry, that is the sine, sine pi x upon 2 over 1, that is the sine 3 pi x over 2 upon 3 plus so on. So the series will be in the form of this interval 0 to 2. So as a particular case, they can give you any intervals. Suppose they give you 0 to 1, so we'll use the value of L as 1 and write down the series. So this is by this way we can find out the half range of sine series. Half range of cosine series. Find out the half range cosine series for the function. Find out the half range cosine series for the function f of x is equal to sine pi x upon L, and in the interval 0 to 1. In the interval 0 to L, not 1. Particular case is not given. This is the standard interval with the period L. Now, you know that the formula for half range sine series will be f of x is a naught by 2 plus summation n is 1 to infinity. That is a n cos of n pi x over n. And now we need to find out the Euler constants a0. First Euler constant is a0, that is 2 by L, that is 0 to L, f of x dx. Now you can use the value of f of x, and f of x is 2 by L, 0 to L, and that is the sine pi x over L dx. Now you can integrate with 2 by L. Integration of sine is minus cos pi x over L over pi over L with the limits 0 to L. And this is 2 by L minus sine can be written out and value of x as L. And for the lower limit 0, cos 0 is also 1. So that is minus 2 and 2 will be 4, 4 upon 5. So this is your value of first Euler constant. And out the second Euler constant 2 by En, that is 2 by L, 0 to L, f of x into pi x over dx. So use the value of f of x, that is sine pi x over L into cos of n by x over L dx. Now, for integrating it, we must require the formula of 2 sine A cos B, and it means this tool can be used over here. This tool, the tool, and divided by 2 also, and it will be removed. That is the 1 by L 0 to L. Now the formula is, that is the sine of a plus b n plus 1 into pi x over L, and minus sine of a minus b pi x over L. Now what it will be, you can integrate it now 1 by L. Integration of the sine is minus cos of n plus 1 pi x over L over pi over L, and the integration of sine is minus, and this minus will give you plus cos of n minus 1 into pi x over L into pi over L 0 to L. You can substitute the values of the limits. That is 1 by L is there. Pi over L is common in the denominator, and it can be taken out over here, and that will become L over pi. And for upper limit L, this will give you minus cos of n plus 1 into pi, plus similarly you will get cos of n minus 1 into pi, and ultimately for the lower limit it will give you plus 1, and one more thing, there should be n plus 1 also, there should be n minus 1 also, because the coefficient is n plus 1 should be there, and ultimately this should be n plus 1, this should be n minus 1, and it should be n plus 1, and it should be n minus 1. These values are for lower limit 0. When you substitute 0 here, cos of 0 will give you 1. So this L is cancelled, you will get 1 over 5. Now you can solve this numerator term separately over here, and it will give you cos n plus 1 into pi, and cos of pi plus n pi. Clearly it is in the second quadrant, it is in the third quadrant, and in the third quadrant cos will always be negative. So negative cos of n pi, and it will be minus 1 raised to pi n. So this minus and this minus will give you plus minus 1 raised to pi n over n plus 1. And similarly we can solve this term also, cos n pi minus pi, and in the second quadrant cos is again negative, and that will be minus cos n pi and minus 1 raised to power n. So minus 1 raised to power n over n minus 1 plus 1 over n plus 1 minus 1 over n minus 1. Remember, this value will not exist for n equal to 1. Here, you will get 0 in the denominator and infinite value in these two fractions. So this case is not possible for n is equal to 1. Now you need to find out the values by taking cases when n is odd. So when n is odd, you can find out the value of the constant n, and the value is, when you will write down n is odd, so plus 1, and it will give you negative value, and negative 1 negative will give you positive value in the case of odd. So ultimately, you see this term will be cancelled with this, and this term will be cancelled with this. So you see that the value of an will become 0 for our number. But in the second case, let us find out the value for even. When n is even, the value of en will be 1 over I, that will be 1 over n plus 1, and that will be minus 1 over n plus 1, n plus 1 minus 1 over n minus 1. The terms are same, it will become 2 times 2 over pi, 1 over n plus 1 minus 1 over n minus 1. We are taking 2 as common. So, what will you get? You will see that it comes out with a negative 4 upon pi and n square minus 1. By taking LCM, you will get this value. And take the LCM and see that the value will become this one. This will be your value of an when n is even. Now, you can write down the value and the value. We can also find out the particular case because we have found the value when n is not equal to 1. So for n equal to 1, we need to find out the value separately. A1 will become, that is 2 over L, 0 to L, and f of x. What is f of x? That is the sine pi x over L. And whatever you are called, that is cos, the formula is cos n pi x over L. So you need to use n is equal to 1 over L. And the new formula for pi x over L. Will become cos pi x over L dx equal to 1 over L. The formula is, that is 2 sine cos it. That is sine 2t. Sine 2 pi x over L will become, using the formula. Now you can integrate it 1 over L. The integration of sine is minus cos 2 pi x over L, 2 pi over L. The limits are 0 to L. Now you can substitute the limits, let it be sign out, L over 2 pi can be taken. You substitute L is equal to x is equal to L. L will be cancelled. Cos 2 pi is plus 1 minus cos 0 is 1. So ultimately it will give you 0 value. So there is no separate value of A1 exists. This comes out to be 0 value. Now you can substitute the values of the constants. A0 is 4 over pi and An is minus 4 over pi n square minus 1 in the Fourier series. The Fourier series will become f of x is equal to 4 over pi upon 2 plus summation An is minus 4 over pi n square minus 1 into cos of n pi x over L. And remember, often exists only for n is even. When n is odd, the value becomes 0. So it means you need to write down this value exists for n is equal to 2 and 4. Value exists for n is equal to 2, 4 and so on. That will become 2 over pi and minus 4 over pi can be taken. You can put the value that n is equal to here. Ultimately you will get cos of 2 pi x over L divided by 2 square 4 minus 1, that is 3. therefore we will write down cos 4 pi x over L divided by 4 square is 16 minus 1 15. So that will be 15 can be written 3 into 5, that can become 1 into 3. Similarly, the next term will be 6 pi x over L, and that is 6 square minus 1, that is 35. And that should be 6 square minus 1, that is 35. And the 35 can not be separated, it can be written straight away. So there is no pattern existing. Sorry, pattern exists. That is 5 into 7. 5 into 7, 35, and so on. So this is the required Fourier series of the given function f of x. And what was your f of x? F of x was a sine pi x over L. And you see, this is the half range cosine series. Similarly, we can also find out the half range sine series of this question also. So by this way, we can find out the half range sine series and half range cosine. Now, we have related to the Fourier series, we have a different type of wave functions. This is also in your course, wave functions, and we shall discuss the wave functions in the next class. Thank you. Thank you very much.